Good morning, everybody. Today we will be wrapping factoring up, okay? And today we're going to be doing factoring by grouping. So far, you guys know how to factor out a GCF. You know how to factor trinomials that are in the form of x squared plus bx plus c. You know how to factor trinomials that are in the form of ax squared plus bx plus c. You know how to factor special cases like perfect squares, which are in the form of a squared plus 2 times a times b plus b squared. That factors out to be a plus b. Or a squared minus 2 times a times b plus b squared factors out to be a minus b squared. And then you have a difference of squares, which is a squared minus b squared, factors out to be a plus b times a minus b. And I also taught you the sum of squares, which is prime. Does not exist. Today, we're talking about 4-term polynomials. And when we have 4-term polynomials, we're going to factor these guys by grouping. Sometimes you have to factor 4-term polynomials, which is very easy. The goal is to create, here's the key, guys, create identical binomials, which are then grouped, bless you, which are then grouped together and factored out. Here's how it works. Very simple stuff. You're going to love this. Factor the polynomial. Okay. We have 4 terms, so right off the bat, it's not a trinomial. We can't use that. We can't use the cubic method. We can't use the column method. It's not a perfect square. It's not a difference of squares. With 4 terms, you have one choice. Grouping. So group 2 terms forming 2 binomials using parentheses. So take the first 2 terms, encapsulate them in parentheses. Take the second 2 terms, notice how I kept the sign inside of the parentheses. And then add the 2 together. So I encapsulated the first 2, then I encapsulated the last 2, keeping the sign, and then I put a plus here in between them. Does that make sense so far, guys? Group 2 terms forming 2 binomials using parentheses. Yes, sir. You can't. Just trust me. Trust me. Sometimes you can't combine the like terms. Sometimes you can. Sometimes you can. In this case, though, that's going to be negative. Yeah, in this case, you could have done that. There's going to be a lot of cases, though, that you cannot do that, and you have to follow this procedure, okay? So, and I'll tell you factor, whenever you have 4 terms, factor by grouping. Step 2, factor out the GCF of each binomial, which leaves you with 2 identical binomials. You are trying to see, what do I factor out of here? Okay, and what do I factor out of here to make them both identical? Identical, the same. So let's check this out. What can I factor out of 3n squared minus 12n? I can factor out a 3n, right, guys? What can I factor out of positive 2n minus 8? Okay, let's see what happens here. When I factor out my 3n, I'm going to be left with 3n times n minus 4. When I factor out my 2, I'm going to be left with 2 times n minus 4. Look at what I just created here. 2 identical binomials. I'm going to sit there for a second. Make sure you see that and understand that. I just factored out the 2 sets of binomials that I just grouped together. I factored something out of each of them to create 2 identical, bless you, 2 identical binomials, which in this case, the identical binomials are n minus 4. Does that make sense so far, guys? Okay. Step 3. Factor out the common binomial and group the GCFs as its own binomial. My friends, now that I'm at this stage, what can I factor out of this whole term and this whole term? Guys, remember, a term is just a bunch of combinations of multiplications. I have 3n times n minus 4 and 2 times n minus 4. What can I factor out of both of these terms? An n minus 4. So when I factor out an n minus 4, guys, I factor out an n minus 4, what am I left with? 3n? No, just plus a 2. 3n plus 2. Oh, whoa, what happened there? Well, that's what should have been there. Okay, I don't know what happened there. But yes, nice and neatly now. Why is that not here? Oh, well, I'll just do it right now. Right quick. So yeah, you're going to have n minus 4 and times 3n plus 2. And that's that. And that's how you factor by grouping. Does that make sense, boys? Okay, so let's go over it again. All right? I'm going to go over it one more time from the beginning. What? Let me do it all fresh. Okay, I hopefully have an answer. Group two terms forming two binomials. You're going to add the two binomials. If this guy is a negative, you keep it inside. If it's a positive, you keep it inside. You keep that inside. Hence, when I said this, guys, look at the way I did this. Didn't I keep the positive inside? Whatever sign this is, if it's a negative, it stays inside. If it's a positive, it stays inside. Great question, son. Does everyone understand part one? You're always going to add the two binomials that you created. Even if this was negative, that would be positive and that would be negative. But you're always adding the two binomials you created. Thank you for your honesty. Any questions on part one? Step one. Step two, factor out the GCF of each binomial, which leaves you with two identical binomials. So I factored out a 3n from this guy, leaving me with n minus 4. And I factored out a 2 from this guy, leaving me with n minus 4. Isn't n minus 4 and n minus 4, aren't they identical? That's the goal. Now, step 3, factor out the common binomial and group the GCFs as its own binomial. Isn't the common binomial here n minus 4? So can't I factor out the n minus 4? And I'm left with 3n plus 2? Does that make sense, gentlemen? Talk to me, boys. This is the last lesson of the chapter. Sir. If you don't have two equal terms, you got to keep factoring until you do. Thank you, sir. That's a great question. Thank you. May I continue, gentlemen? Okay. Let's put it all together. When you are asked to factor, remember the following strategies, guys. Always factor out the GCF if possible, no matter what format you have. If you have 2 terms, 3 terms, 4 terms, 57 terms, it doesn't matter. Always factor out a GCF first. Step 2, if you have 4 terms left, you're going to factor by grouping, if possible. Sometimes you group and it's not possible. If you have 3 terms left, identify any perfect square trinomials. If none, factor normally. With trinomials, remember, if it's x squared plus bx plus c, it's simply the setup of x and x, and then what times what is c, but when added together is b. If it's in the form of ax squared plus bx plus c, then it is, the setup is ax, multiply the a and the c, what times what is the new C, but when added together is the B. That's the cubic method. We also know the column method. All of those methods are used for 3 terms, trinomials. And step 4, if you have 2 terms left, identify any difference of squares or sum of squares. If you have a difference of squares, well, then you're done. If you have a sum of squares, it's prime. You're done. Okay? But always factor out that GCF if possible. Really, really important. A lot of times people forget to do that, and that's going to cause the whole entire problem to be wrong, usually. Because then later on it gets a little confusing, you don't know what to do, and then you just start putting numbers out. Does that make sense, gentlemen? All right? So, okay. So let's practice. Factor each polynomial completely. Step 1. I am going to parentheses around both of these bad boys. You with me? Okay. What can I factor out of here? 2q cubed. And I'm going to be left with 2q minus 5. Plus q cubed divided by q cubed is 1. Thank you, bro. Okay, what am I factoring out of here to make it look exactly like 2q minus 5? An 8q, very good. Am I taking out a positive or a negative 8q? Positive. So I go plus 8q, right? Oh! Wrong. Epic fail. Mr. Morrow, learn how to pay attention. Mr. Morrow, practice what you preach. Did we even check to see if we could factor out a GCF? No, I did not, and that would have caused me to have a very complicated ending. So, Mr. Morrow, pay attention. Class, you forgot as well, pay attention. We got to factor out a 2 first. So, I have 2q to the, actually, 2q. I can factor out a 2q. So, I've got 2q cubed. No, I took out a 2q. 2q cubed minus 5q squared plus 8q minus 20. Now, let's group it. So you take your first 2, and you take your second 2. Is everyone with me so far? Okay. I got to have my 2q that I factored out, though, always. All right, what am I going to factor out of this bad boy? Huh? A q squared, right. So I can take out a q squared. I'm left with 2q minus 5. What do I factor out of this bad boy?
4.
A 4, very good. So plus 4, and I got 2q minus 5. Is everyone with me so far? Is everyone with me so far? Is everyone with me so far? Okay. So then this is going to equal at the end. Isn't this binomial and this binomial, aren't they the same? So I factor that out as 1, and I have the leftover GCFs as another binomial. So I have 2q, which is the GCF, times 2q minus 5, which is the binomial I factored out, times q squared plus 4. If this was a minus 4, I could factor that. What kind of a factor would that be? Guys, if that was q squared minus 4, how would I factor that? Guys, if that was a if that was written like that, how do I factor that?
Q minus 2.
Q plus 2, Q minus 2. It's called the difference of squares. We have a test on this in 2 days, and you guys don't know that? I suggest strongly that you start reviewing. I suggest strongly. Thank you. But since it's not minus, it's plus, that's a sum of squares, and a sum of squares is not factorable. It is prime. Next, number 2. Can I factor out a GCF? No. So I'm going to have to go straight to grouping. Now please pay attention to this. I take the first 2 and the second 2. Notice how I included the negative of the 5r. Notice that. You with me? What can I factor out of this first binomial? 2r squared. Thank you, son. 2r squared, so that's r plus 6. And then, what do I factor out of this to make it look like r plus 6? A negative 5. Thank you very much, son. Fantastic. R plus 6. Now I have two binomials that are equal. So my answer is I factor out the same binomial. What am I left with? 2r squared minus 5. The 2r squared minus 5, that is not a difference of squares, so I cannot factor it, and I am done. Sir? I did pull out a negative 5, sir. Does that make sense, gentlemen? Questions, gentlemen? Okay. Let's see. What else we got now? Next, can I factor something out? What? Higher than a 2? A 4. So what am I going to be left with? 2p cubed 7p minus 8p squared. Good job, son. 20. No. That goes in. No, it doesn't go in. That goes in 1 time 8. Guys. Oh my God, guys. Please stop saying 28. It's not even remotely possible to be 28 because 8 times 8 is 64. So please stop repeating it. It's 14. Come on, man. Okay. You were dividing by 4. Okay. So 4. Now it will be 28. Yes. Wait. No, 2, 8, 3. Yeah. Okay. Okay. I thought you were dividing by 8. Thank you, guys. So 28. Okay. Now, let's factor. I group this guy and this guy together. I group this guy and this guy together. What can I factor out of here, if anything? A p, right. So I have 4. And I have a p times 2p squared plus 7. Now what do I factor out of this bad boy to make it look like 2p squared plus 7? A negative 4. Thank you, son. Pull out a negative 4, and I'm left with 2p squared plus 7. Guess what? Now I have my two identical binomials. I pull those guys out. I factor them out. When I factor them out, what am I left with? A p minus 4, and of course, the GCF of 4 that I took out from the beginning. GCF always stays outside. Thank you, son. Does that make sense, gentlemen? Promise? Okay. Yes, sir. What did I do on the bottom? Well, don't I have a 2p squared plus 7 and a 2p squared plus 7? I factored that out as one term. I factored it out. Guys, it's kind of like the GCF. Look, guys. What's the GCF of this and this? Yeah, isn't 2p squared plus 7 in both of these terms? Guys, I'm just pulling out the GCF. Don't I pull the GCF out here? And then don't I put the leftovers, which is p minus 4? And of course, this GCF has to stay. Always. Thank you, son. Does that make sense? Anyone else? Honesty is the best policy. All right. You good, my man? Thank you. Yes. Oh, okay. Next. Factor each completely. All right. Let's see what we got here. We got 8x cubed minus 64x squared plus x minus 8. Can I factor anything out GCF-wise? No. So I'm going to group it because there's 4 terms. What can I factor out of these first two?
8x squared.
An 8x squared. Very good. So I'm going to be left with 8x squared
No,
times
oh yeah, 8 squared. Yeah, my bad. It's the first
times
x
x
minus.
minus 8. Very good. Okay, now, I did this one on purpose. This is already x minus 8, correct? But I need to factor something out. What can I factor out of there to keep it the same? A 1. Thank you. So you factor out that 1. You got x minus 8. Now again, you're factoring out the common term. X minus 8 is common to both of these terms. So I factor out the common binomial, x minus 8, and I'm left over with x squared plus 1. Does that make sense, gentlemen?
Sir.
Number 2, can I factor anything out? No. So I group it. What can I factor out of each of these bad boys? 3w squared for sure. So I got 3w squared times 4w minus 7. And then what can I factor out of 28w minus 49? A 7, very good. So I factor out a 7, and I got 4w minus 7. Now I have created my 2 identical binomials. I factor those bad boys out. 4w minus 7 times the leftovers of 3w squared plus 7. Does that make sense? Yes, no, maybe, kind of, sort of? Okay. Let's continue then, please. Thank you. Can I factor anything out of number 3? No. Okay, go ahead. Actually, yes, you can. Yes, you can. I should have tested it. Yeah, 2 plus 1 is 3. 8 plus 4 is 12. That's divided by 3. 15 is divided by 3, and so is 60. Thank you, son. So first factor out of 3. So I'm left with 7y cubed minus 2 is 6, 28. Y squared plus 5y minus 20. Thank you. Good catch, kid. Now, let's group it. Okay, what can I factor out of this bad boy right here? Remember, you have that 3. Don't ever forget that one. So I'm going to take out a 7y squared. Very good. 7y squared. I'm left with y minus 4. And then I can take out a. Very good. So I got y minus 4 again. Hey, look at that. Now I have my 2 common terms again. My 2 common binomials, rather. I factor those out. So I've got 3, which is the GCF, times y minus 4, which is the binomial I factored out, times the leftover primes of y squared plus 5. Is everyone with me here, gentlemen? Yes? Okay. Next, number 4. Can I take anything out of there? 4? No. 4 doesn't go into 25. So there's nothing here. Okay, what can I factor out of 40wy squared plus 25wx squared? A 5. A 5w. Very good. So I'm going to be left with 8y squared plus 5x squared. What do I factor out of these 2 bad boys?
4k.
A 4k, very good. So I've got plus a 4k that I factored out times 8y squared plus 5x squared. So once again, I have my 2 binomials that are identical. I factor those out. So when I factor out the ay squared plus 5x squared, I am left with the binomial formed by my leftovers of 5w plus 4k. Does that make sense, gentlemen?
Yes, sir.
Okay. Now, in this case, let me show you what happens. If I go ahead and group it, what can I factor out of here?
Two.
A 2. So I'd have 2ab plus 3. Uh-oh. What can I factor out of here? A negative 1. Okay. Wait a second. Wait a second. Are these identical? Okay. Sometimes you're going to have a situation like this. Do not stress. Simply do one procedure to see if it's possible. If in the original setup it doesn't work, erase what you did and literally put this guy here and this guy here. Switch them. So rewrite it as 4ab minus a plus 6 minus 24b. Now, let's see if we can group them. That's all you have to do, guys. If it doesn't work on the first setup, switch the places of these two along with the signs. If you switch them and now we test it, if it still doesn't work, then okay, fine, we're out of luck. You with me? Yeah, you would put prime then, okay? But let's check, let's check. Okay, I'm going to get these two together. I'm going to factor out of here an a. Very good. So that's going to be 4b minus 1. Bless you. What can I factor out of here, guys?
6.
Okay, think about it. Don't I want a positive 4b? If I factor out a 6, I'll be left with a negative 4b. So factor out a negative 6. If I factor out a negative 6, now I'm going to have negative 1 plus 4b. Are those two binomials identical? Yeah. Of course, it's a positive 4b and a negative 1. Perfect. Factor those out. 4b minus 1 times the leftover binomial of a minus 6. Come again, what? Okay, no, remember this is the commutative property. You have a 4b plus a negative 1. You have a negative 1 plus a 4b. Same thing. Thank you, sir. What you cannot do is this, Raul. If you have 5 minus 3, that does not equal 3 minus 5. There's no way on earth. But 5 minus 3 does equal negative 3 plus 5. You see the difference? Because if I just go 3 minus 5, that's going to be negative 2. 5 minus 3 equals 2. Negative 3 plus 5 equals 2. So you can switch them around as long as you keep that negative with what you're moving around. You with me? Thank you, son. You're welcome, my brother. Okay, last but not least. Can I take anything out of here? Yeah? Someone says yes, someone says no. Okay, I know it's tempting. You can take a 7, a 7, a 7. But you can't take a 24. You can't take a 3 from 49. Because 4 plus 9 is 13. Thank you, though, for trying, sir. So, we're going to go ahead and group it. What can I factor out of this bad boy right here? Excuse me, a 7x is exactly correct. That's a w plus 7k. Did we do this one already? No. And then, what can I factor out of here? A negative 3y. Very good. So you factor out a negative 3y, and I'm left with 8w plus 7k squared. Wait a second. It's just a typo. There should be a k here. That k should be squared. My bad. Sorry. No excuses. My bad. No excuses. It's my fault. I know I make mistakes. Everyone makes mistakes, but remember, the difference between an adult and a small child is the adult takes responsibility, and that was completely my fault. I made an error. Thank you for understanding, guys. So yeah, so thank you, bro. So that's squared and that's squared. So now I have 8w plus 7k squared, 8w plus 7k squared. Factor that bad boy out. 8w plus 7k squared times the leftover binomial of 7x minus 3y. Does that make sense, gentlemen? You are done with factoring. This is something you cannot forget. We're going to come back to this in Chapter 9, and we're going to come back heavy in Chapter 9. So you have to really, really know this, guys. We're going to practice for the rest of the class. God bless you. Thank you for a good class. Have a great day.